Hello. In this video, we're going to talk about congruence. Now, congruence means a figure that has the same shape and size as a different figure. All of the rigid motions that we've been talking about, reflections, translations, and rotations, are congruent to each other. That means all the sides are the same length and all the angles are the same measure. These are called congruence transformations for that reason. We take one figure and we do any sort of congruence transformation or rigid motion to it, and it creates a new congruent figure. Okay? The symbol down here that has that equal sign with a little squiggle on top of it is the symbol we use to mean congruent. So we read it just like is congruent to, just like we would read an equal sign as is equal to. Okay? Let's take a look at some congruent figures. In this figure, we have triangle XYZ and triangle ABC. Now, what we want to know is what rigid motions, again, rotations, reflections, or translations, are going to move triangle XYZ onto triangle ABC. Now, just by looking at it, I can sort of tell that there's been a rotation here of some sort. I can tell that because if I were to do a flip over the x-axis or the y-axis, the way this figure would land is not the way that the figure we have in ABC has landed. So we must have done some sort of rotation. So let me start by rotating figure XYZ, and I'm going to go 90 degrees. So I'm going to rotate 90 degrees. I'm going to go counterclockwise about the origin. Now, if you recall, what this means from our rules is that when we go from x comma y, those will translate or transform into negative y comma x. So for instance, point Z, which was at 0 comma negative 2, will go toward where Z would land. We will switch these, and that 2 becomes positive. X, which was at 5 negative 1, will go toward its image, where we switch. The 1 becomes positive, and they switch the order to 1 comma 5. And then y's originally was 3 comma 2, and it will transform to its image, which is negative 2 comma 3. Just to show you what that looks like, Z will go here, X will go here, and then Y would have landed here. So if I draw this in, this is the triangle that we have now after just a rotation. And so you can see how this triangle looks like triangle ABC. So a rotation of 90 degrees is one thing that needed to happen. What still needs to happen? Well, notice from this point we just need to go down and over. In each case, it's down 1 and over 3. So this is a translation of, well, we'll say left 3 and down 1. And so, I mean, this is enough here with these two pieces of information. If we wanted to write our rule on this, we would go from x comma y to, and now we did that negative y and the x, but we're going to take our left piece, which is that first number, we're going to subtract 3, then we're going to take our y, we're going to go down 1. So both of them would be negative because they're moving in the negative direction. And so you can see that when we take our y, let's just take y. Y started at 3 comma 2. Now y, which is the second letter, should land on b, which goes to negative 5 comma 2. So we should get b here by doing, well, my y value is 2, so we'll have negative 2, then minus 3, comma, then my x value was 3. So I'll do 3 minus 1. And so b should have landed at negative 5, comma, 2. And lo and behold, there it is at negative 5 comma 2. Okay, so this is the rule that tells us how we move things around, the function where we take our inputs and we should get very specific outputs. And then this is the verbal with these two pieces of information. We needed to have both of them in order to do it. So this is a rigid transformation because, I mean, we knew this because the two triangles are congruent. And so now we have the motions that map it. A 90-degree counterclockwise rotation about the origin, and then a translation left 3, down 1. Okay, for now we are done.